Whenever I think of equivalent fractions, I always remember that a half is the same as 5/10, or the same as 10 out of 20, or the same as 50 out of 100. What do all those fractions have in common? When you simplify them by dividing both top and bottom by the highest common factor, they all equal a half. So that means that to write any fractions that are equivalent to 3/5, we need to multiply both top and bottom by any number as long as they are the same. So for example, I'm going to write that 3/5 multiplying the top and bottom by 2 equals 6/10, or multiplying the top and bottom by 3 equals 9/15, or multiplying the top and bottom by 4 equals 12/20. And if I simplified all three of those fractions to their simplest equivalent, they would all simplify down to 3/5. Now, my strategy for the second question is to try and simplify all of those fractions to their simplest possible form. As soon as we've got them in their simplest possible form, then we can see the equivalent ones will be exactly the same. So we need to decide whether they're in the simplest possible form first. So 3/8, I can't think of a number that both 3 and 8 can be divided by, so that's already in simplest form. 4/15 is already in simplest form. I can't find a number that both 4 and 15 can be divided by. 1/6 is also already in simplest form. However, 5/30, I can think of a number that both 5 and 30 can be divided by, and that is they can both be divided by 5. So I'm going to rewrite that as 1/6. Alright, 2/3 I can't simplify, but 3/18 I probably can. 3 goes both into 3 and 18. So I'm going to rewrite that as 1/6. Ooh, look, we've got some equivalent fractions happening already. Alright, 8/48. I think that 8 is a common factor to both the top and the bottom of that fraction. So dividing the top by 8 gives me 1, and dividing the bottom by 8 gives me 6. Look at that. 2/12. If I simplify that by using the highest common factor of 2, I also get 1/6. How about I start circling these as I go along? That would help. Otherwise, I'm going to forget them. So all the ones that simplify down to 1/6 are going to be equivalent fractions. Alright, what's the next one I'm up to? 10/80 will simplify by dividing top and bottom by 10, but that will only simplify to 1/8, not 1/6, so it's not an equivalent fraction to anything that we're listing yet. 15/90, 15 would be a common factor to that one, so the top would be 1, and how many 15s go into 90? I believe 6 of them. So that's another equivalent fraction because it simplifies down to 1/6. So 14/84, can that simplify? If you can't think of a number that goes both into 14 and 84 straight away, how about you think that of a smaller number that might work? For example, I think both 14 and 84 can be divided by 2, and that will give me 14 divided by 2 is 7, and 84 divided by 2 is going to be 42. I can go even further. I now can see that 7 is going to be the highest common factor there. So dividing 7 by 7 is 1, and 42 by 7 is 6. And what do you know, 14/84 is also equivalent to 1/6. Now the last one, 12/74, I'm going to take the same strategy. I'm going to divide top and bottom by 2 and see if that gets me anywhere. So 12 divided by 2 is going to be 6, and 74 divided by 2 is going to be 36, and that can simplify down to also 1 over 6. So there are a lot of equivalent fractions here, and I believe that I've now caught all of them. Alright, so we're going to reduce the following fractions to the simplest form. So 15 over 40, I feel that this could possibly be divided top and bottom by 5. So we're going to divide by 5. 15 divided by 5 is 3. And 40 divided by 5 is 8. Do you think that 3 over 8 could be simplified any further? I hope not. Otherwise I would be wrong. Okay, and I hate being wrong. Alright, 14 over 20. I think let's start by dividing by both top and bottom by 2 and see what happens. So 14 divided by 2 is 7, and 20 divided by 2 is 10. 7 over 10. I feel that there are not any numbers that 7 and 10 can be divided by. So we leave it as that, and that's the simplest possible form. 62 over 90. This is going to be interesting. Let's do, because they're both even numbers, I can divide both top and bottom by 2 and see what happens. So 62 divided by 2 is going to be 31. Ooh, that's a bit of a dodgy 3. Okay, and 90 divided by 2 is going to be 45. Yeah, I can't think of any way to simplify that any further. Yep, let's go on. Okay, and part D is 45 over 85. Okay, 45 over 85 are both numbers that end in 5, so I know that 5 is going to work. So 45 divided by 5 is 9, and 85 divided by 5. I think you're going to have to use your trusty calculation machines for this one. 85 divided by 5, according to my calculation machine, is 17. 9 and 17 don't have any common factors, so I can leave it at that. And then 17 over 20, I think, is a trick question because I can't think of any numbers that 17 and 20 can both be divided by. So 17 over 20, and that's it. Alright, in a one-day cricket match, the opening partnership scored 84 runs altogether. If the captain made 32 of these runs, what fraction of the total for the partnership did he run? So if the partnership scored 84 in the total, that's going to go in the denominator. So over 84, and the captain made 32 of these runs. However, is that in simplest form? Perhaps we should try, being even numbers, we can divide by 2 again. So that would equal 17 over 42. The captain made 17 out of every 42 runs for that partnership team. Right, draw diagrams to represent the following fractions. So whenever I'm asked to draw a diagram for a fraction, I always think of pizzas. So I'm going to eat 3 1/4 pizzas, and I need to draw that in a diagram. So I'm going to draw 3 whole pizzas first of all. 3 whole pizzas. Then I'm going to draw another pizza, but I'm going to divide it into 4 parts, and I'm only going to have 1/4 of them. So then I'm going to colour in the whole pizzas that I already ate, because I was hungry. And that's 3 1/4 in diagram form. So 2 5/6 pizzas. So I'm going to eat 2 whole pizzas, 1 whole pizza, 2 whole pizzas. Then in my third pizza, I'm going to actually divide my pizza into 6 parts. And then I'm going to eat 5 of them. 1, 2, 3, 4, 5. That is 2 5/6. Now the third fraction is 7 over 8. And I saw some fantastic diagrams, something like this. Now, you could do this, you could do blocks for any of these. So I have 8 parts altogether. So I'm going to divide my block into 8 parts. And I'm going to take 7 of them. So let's see. Let's put a little tick in every part that I'm going to take. And I've taken 7 out of 8 parts. So 4 3/4. So maybe I'll eat pizzas again. Yeah, so 4 pizzas, they're just easier to draw. 1, 2, 3, 4, and I'm going to have 3/4 of the last pizza. So I'm going to divide my pizza into 4 parts and eat 3 of them, and I'm done. Okay, the next question is to change some mixed numbers into improper fractions and then express in the simplest form. And that means to simplify them, but only if you can. Sometimes a fraction can't be simplified. And that's life, we've just got to move on. So here are the questions. Alright, the first one is 2 3/4. So when we change a mixed numeral into an improper fraction, we need to multiply the big number with the denominator. So 2 times 4 is 8, and then add the number on the top. So 8 plus 3 is 11, but on the bottom our denominator stays the same. So we have 11/4. So if we put that in pizza form, and our pizzas were all in quarters, because we've got 2 whole pizzas plus 3/4. All of our pizzas are actually in quarters. It's just that we have 4/4 here and another 4/4 here, and that makes 2 wholes plus 3/4. So 2 wholes is actually 4/4 plus another 4/4 plus 3/4, and when we add fractions with a common denominator, we just add the numerators and leave the denominator the same. So how many quarters do I have altogether? 4 plus 4 plus 3 equals 11/4. And that's why that method works. Alright, so part B was 7 1/3. So to convert that from a mixed numeral into an improper fraction, we're going to multiply the big number with the denominator, 7 3s are 21, and add the 1, which is 22. And we're going to keep the denominator, which was 3. So that's 22/3 altogether. Part C is 4 2/5. To keep with our awesome method of doing this in the most efficient way, we're going to do 4 5s are 20. 20 plus 2 is also 22, but there's 22/5 altogether this time. So just remember that if we put that in a diagram, I'm going to have 4 pizzas, 1 2 3 4, and they are all divided into 5. Like that. Okay, so, and I'm going to have all 5/5 of the first one, 5/5 of the second one, 5/5 of the third one, and 5/5 of the fourth one. And the fifth one I have to have 2/5 of. So oops, I've been dividing into 6. My bad. Okay, and in the final pizza, I'm going to have 2/5. So if I've eaten all of that, all of that, all of that, all of that, so 4 whole pizzas plus 2/5, I have how many fifths altogether? 5, 10, 15, 20, 22 on 5, which is what we want. Okay, so part D is 11 3/8. So 11 wholes and 3 eighths. Okay, so we need to multiply our big number by our denominator. 11 eighths are 88. 88 plus 3 is 91 eighths altogether. And the last one, part E, is 14 and 6 tenths. Okay, so 14 times 10 is 140. Remember, when we multiply something by 10, we just add a 0. So 14 times 10 is 140, plus 6 is 146 tenths. However, have I answered the question? The question said I had to simplify. None of these improper fractions had any common factors so far, except for 146 over 10. And straight away, because they're both even numbers, I can see that I can divide by 2. And let's see what happens when I do that. So 146 divided by 2 is 73. Use your calculation machine if you need to for the bigger numbers. That's fine, because we're not testing if you know your 146 times tables. We're only testing if you know how to simplify fractions. So, and then 10 divided by 2 is 5. I don't see any more common factors between 73 and 5, so we're good to go. Alright, this next question is question 7, and it says to change these improper fractions to mixed numbers and express in simplest form. So it's exactly the opposite of what we were just doing. So this is question 7, part A, which is 7 over 5. So we're going to ask ourselves, how many 5s go into 7? And I think there is one of them. So we've got one whole, and after I divide 7 by 5 and decide it goes into it once, I've actually got 2 left over. And keeping our denominator the same, we've got 1 and 2 fifths. Can 2 fifths be simplified any further? I don't see any common factors, so let us move on. Okay, the second question is 21 over 6. So we need to know how many 6s go into 21. I know 6 3s are 18, so probably 3 whole 6s go into 21. That brings me up to 18, so I need to know how many are left over. So after 18, 19, 20, 21, so there are 3 left over, 3 sixths. So I need to simplify. I've got 3 wholes. 3 over 6, however, is the same as 1 over 2, so it's 3.5. Next one, I've got 24 fifths. How many 5s go into 24? 5 5s are 25, but that's too many, so 5 4s will bring me up to 20. So I've got 4 left over, 4 fifths, and I can't simplify that any further. Okay, 156 tenths. That's an interesting one. I want to know how many 10s go into 156. I know that 10 15s are 150. So because anything multiplied by 10, you just add a 0 onto it. So 15 10s are 150. So I have 15 wholes. That brings me up to 150. And I have 6 left over, 6 tenths. However, I can simplify that further. I can divide 6 and 10 both by 2. So when I divide that by 2, I get 15 and 3 fifths. And the last one is 38 thirds. How many 3s go into 38? Ooh, that's an interesting one. 3 9s are 27. 3 10s are 30. 3 11s are 33. 3 12s are 36. That's as close as we're going to get. And we've got 2 remaining, so 12 and 2/3, and we have smashed question 7. Alright, question 8 is place the following fractions in descending order. So we need to find what's the biggest one and all the way down to the smallest one. So I will write them all out. Here we go. Alright, in order to compare them, they kind of need to have the same denominator. So I'm going to look for the lowest common denominator. So I'm thinking it's going to be 24. So I'm going to have to write everything as a fraction over 24. So 3 over 24 is already something over 24. How do I make 12 into 24? I'm going to have to times both top and bottom by 2. So 5 2s are 10, 12 2s are 24. We're over 24, we're all good. How do I make 2 into 24? Times by 12. 1 12 is 12, 2 12s are 24. 8 times 3 is 24, so I times 5 by 3 is 15, over 8 3s are 24. 4 times 6 is 24, so 3 6s are 18, 4 6s are 24. All I'm doing is writing equivalent fractions, but writing equivalent fractions allows me to compare the size of them. Okay, 6 4s are 24, so I multiply top and bottom by 4. And finally 3 8s are 24, so 2 8s are 16 over 24. So now I have the slightly less difficult job of writing them in descending order from biggest to smallest. So all I have to do now is find the biggest numerator. So that looks like the 18. So I'm going to write the biggest fraction first. Then what's the next biggest one? 16 over 24. Then the next one is 15 over 24. Then the next one is 12 over 24. Then the next one down, 10 over 24. The next one down, 4 over 24. And the last one is 3 over 24. But I actually have to now rewrite these in the fractions that they originally were, so their simplest form. So 18 over 24 was, what's the highest common factor of that? Let's simplify them back down. I think it is 6. So 18 divided by 6 is 3. 24 divided by 6 is 4. Alright, so that one is done. 16 over 24, I think the highest common factor here is 4. 16 divided by 4 is 4. 24 divided by 4 is 6. We can simplify that further. Divide both top and bottom by 2. 2 over 3. So that's that one done. 15 over 24, I think the highest common factor there is 3. So 15 divided by 3 is 5. And 24 divided by 3 is 8. I'm going to put a comma between each of them so we can be sure to separate them. 12 over 24, the highest common factor there is 12, and that's straight away a half. That one's done. 10 over 24, let's try dividing top and bottom by 2 because they're both even numbers. So 5/12, and no, I can't simplify that further because there are no more highest common factors. 4 over 24, highest common factor is 4. So 24 divided by 4 is 6. Lucky last one. Highest common factor of 3 over 24 is 3. 3 divided by 3 is 1. 24 divided by 3 is 8. And we are finally done with question 8. Love it. Alright, question 9. A catering company provided 10 cakes. So we have 10 cakes. And which were cut into 8 pieces for a luncheon. So all of these 10 cakes were cut into 8 pieces. Cut into 8 pieces. So at the end of the lunch there were 8 pieces of cake left over. How many whole cakes were eaten? Ooh, this is interesting. I would love to know how many pieces of cake there were at this lunch altogether. If I have 10 cakes and they're cut into 8 pieces each, I probably have 10 cakes, 8 pieces each. I have 80 pieces of cake altogether. I know that there were 8 pieces left over. 8 pieces left. So if there were 8 pieces left, how many pieces were eaten? I had 80 pieces, 8 left over. So 72 pieces eaten. But I want to know how many whole cakes were eaten. I have 72 pieces and there were 8 pieces in each cake. So if I divide 72 pieces by 8 pieces per cake, 72 divided by 8 is 9. So I've got 9 whole cakes were eaten. Another way of knowing this, though, was if I had 10 cakes altogether and there are 8 pieces per cake and there's 8 pieces left over, I must have 1 whole cake left if there are 8 pieces per cake. So if I had 10 cakes, 1 whole cake left, I must have eaten 9 cakes. Well, everybody's eaten 9 cakes altogether. Lucky last question, question 10. All right. A group of young police officers organised a 400-kilometre run to raise money for charity. Let's write down 400 kilometres. The reason is that's a number and I'm given information in a question. As soon as I'm given information, I think that it might be important to highlight it or write it down in case we need it later. There are 5 officers involved and the distances they ran are given in the question. So they are... Here's the distances. What the question is then asking you to do is find the fraction of the total distance that each of the police officers ran. And if it can be simplified, simplify it. So the fraction of the first one is going to be 96 over 400. The fraction for the second one is 84 over 400. Third one is 78 over 400. Fourth one is 68 over 400. And the last one is 74 over 400. You actually might notice something interesting in that all of these distances, 96 plus 84 plus 78 plus 68 plus 74, all should add up to 400 kilometres. So all of the fractions should equal 400 over 400, or if we simplify that, it should be 1, because they've completed the whole course between themselves as a group. So what we need to do now is simplify. I'm noticing that even if I don't know my 74 times tables, or my 96 times tables, or my 84 times tables, they're all even numbers. So let's divide everything through by 2 to start off with and see if that makes it any easier. So 96 divided by 2 is going to be 48. And 400 divided by 2 is 200. So let's do that for all of them and see what happens. So 84 divided by 2 is 42 over 200. 78 divided by 2 is 39 over 200. 68 divided by 2 is 34 over 200. And 74 over 400 is 37 over 200. Now my next job is to see whether any of them can be simplified. So because the question said express it in simplest form. So let's see. 48 over 200, still even numbers, so I can split down again by dividing by 2. So 48 divided by 2 is 24, and 200 divided by 2 is 100. 42 and 200 I can split down again, 21 over 100. 39 and 200 can't be divided down, have no common factors, so we're at our final answer here for this one. 34 and 200 can be both divided by 2, so 17 over 100, and that one can't be divided down anymore. Also, the 21 over 100 can't be divided down anymore, so we've got two more simplest answers here. 37 over 200, I don't know of any common factors between those two numbers, so we're at our simplest answer. And the last thing we've got to do is deal with this 24 over 100. Both even numbers, I can divide by 2 again, 12 over 50, and I can still divide by 2, 6 over 25. And I don't know of any answer, any number that both 6 and 25 can be divided into, so that's going to be my final answer. Oh, that was a long test. I'm tired. Let's stop.